moving along, we ticked off the ones that we have completed, and I filled in all the information on the sketch because we might need it later. So question D says, determine the coordinates of D. So D is over here, and D is also the point of intersection between g of x and f of x. And so we start off by writing an equation where we equate f and g. So we go f of x equal to g of x, okay? Because f of f and g of x will intersect at the point that I just colored in, and also at this point, right? So we already have the second blue dot that I just drew. We now need to figure out where is this one, right? So we equate the two functions as follows. Alright, so now I've substituted the equations of each function, and now we just need to solve for x. So what I'm going to do is I'm going to bring everything to the left hand side, okay, and we find that we get negative x squared minus 2x plus 8 equal to 0, right? But now we cannot factorize this trinomial while the coefficient of x is negative, so we will just change the signs of every term in this equation to end up with x squared plus 2x minus 8, okay? And now because we have a quadratic, we need to factorize this so that we can get two values for x. So we would have to take x and x plus 4 and minus 2, right? And so therefore the two options would be when x is equal to 4 or when x is equal to 2. Now x is equal to 4, we already know this one, okay, because that is over here. And so therefore the coordinates of D would be where x is equal to minus 2, right? That's the x coordinate. To get the y coordinate, we need to substitute this value of 2 into either the g of x equation, because D is on g of x, or into the f of x equation, because D is also on f of x. I would go with this one because that is the easier equation. So I would say, okay, when x is 2, y is going to be 2 times 2 plus 8, which gives us 12. And so therefore point D is at 2 and 12. Okay, so now I've filled in the coordinates of D, 2 and 12. The next question says, if OR is 1, so OR is over here, if OR is 1 unit, determine the length of PQ. Now PQ is a vertical line or a vertical length, and so we need to find the y coordinates of P and the y coordinate of Q. Right, once we have those two things, we can figure out how long that segment is. So now with the information that's known to us, if OR is 1 unit, then that means from the origin to R, we just jumped by 1 unit. And so that would make the coordinates of R at -1 and 0. And we know this because this is on the negative side of the x-axis, right? So R is -1 and 0, because we took a single jump from the origin to point R. So now the new knowledge here is the fact that when you have a perfectly straight line like this, which is indicated by this right angle, if R is -1, then Q's x is also -1. But because P is on the same line, his x will also be -1. And now with that information, we can figure out the y coordinate of P and Q, right? So now we'll start it off nicely. We can say, all right, the y value of P we can get if we substitute into the graph of f of x, right? Because P is on f of x, the parabola. And so we can say that the y value will be 16 minus x squared, but we've already established that x is -1, so this is 16 minus -1 squared, which is 15. So the y coordinate of P is 15, and I will write it in over here. Alright, 15. And now we do the same for q. So to get the y value of q, we need to substitute it into g of x, because q is on the straight line g of x. And now we can say, right, y is equal to 2 times minus 1 plus 8. Again, this equation is coming from g of x's equation, because point q is on g of x. And so when we type this in the calculator, we get an answer of 6. So the y value of q is 6, which I will write in. Alright, and finally, the length from P to Q would then be the y of the top minus the y of the bottom, which is 15 minus 6, which gives us 9. And so therefore, let's just do it over here. Therefore, PQ is going to be 9 units long. Okay, the next question says, if PQ is now 8, determine the length of OR. So over here, right? So basically, we need to figure out how would this point R move, left or right, so that PQ is a shorter length than what we currently see. So if this line PQ moves a bit to the left, it would shorten to possibly 8 units or even less. But that can also happen when we move this PQ segment to the right. And so now we need to figure out the x values, or the x value where that takes place. Okay, so what we do know is that yp minus yq will produce an answer of 8 units. Okay, because that is what was said. The length of PQ is 8. So the y of P comes from f of x. And so we can substitute that equation by saying 16 minus x squared minus yq can be replaced by 2x plus 8. So we subtract 2x plus 8 equal to 8, and then we solve. Okay, so I've eliminated my brackets, and now I'm just going to solve. So 16 minus x squared minus 2x minus 8 minus 8 equal to 0. This simplifies down to negative x squared minus 2x all equal to 0. Okay, then I change my signs by making them both positive. Okay, because this is a quadratic equation, we need to factorize, and so this would be x and x plus 2 all equal to 0, right? And so now our options would be where x is equal to 0 or where x is equal to 2. What this means is PQ will have a length of 8 when P and Q have x coordinates of 0, so that would be on the origin, or when x is 2. Okay, but we now want to find the possible length of OR, right? So we don't want to go with this answer that takes us onto the y-axis, because then OR wouldn't have any measurement, because O and R would be on the same spot. And so we take the value of x equal to 2, right? So if, apologies, x equal to negative 2, not positive 2, okay, let's just erase that. So the second option is when x is equal to negative 2. If you picked that up before I did, good job. So when R is moved just a bit to my left, to negative 2, then the segment PQ, the new PQ, would be 8 units long, right? So that would happen at minus 2. And so if R is now at minus 2, right? If R is now at minus 2, then the length of OR would be from 0 to minus 2, which would be 2 units. And so in this hypothetical scenario on the left, if PQ was the length of 8, then OR would be 2 units, and that is the solution to that question. Okay, so now we move over to translations. So what's being said here is that if h of x, if a new function h of x is f of x minus 7, right, then we are transforming our current parabola and we are moving it down. So, to answer the question of G, describe the transformation. We would say h of x is the graph of f of x shifted 2 units down. Sorry, 7 units down. Okay, and so we take our current graph and we move every single point on that graph down by 7 units. Okay, and so that is the transformation in words, right? So that is what is happening to f of x to form h of x. The next question is, what is the new turning point of h? So if the old graph was turning at 16, when we move it down 7 points, right, then it would be 7 points lower than what it currently is at. So the current graph is at 0 and 16, and if we move it down by 7 units, then our h of x graph, right, will turn at the point 0 and 9. Okay, and so the turning point for h of x would be at 0 and 9, because logically we're just taking the point C with the purple or with the pink value, and we just move it down by 7. Okay, the following question is to determine the x-intercept of h. So we need to find the equation of h first. So h of x was f of x minus 7. So we need to take the f of x equation, which is 16 minus x squared, and then we subtract 7 from it. Okay, and so now h of x is going to be negative x squared plus 9, right? And now with this we can find the x-intercepts. So now to get the x-int, we need to let y equal to 0. So we say 0 is equal to negative x squared plus 9. So x squared is equal to 9, which means that x is therefore positive or negative 3, right? Meaning that this graph will turn at 3, or rather this graph will cut the x-axis at 3 and 0 and minus 3 and 0, right? And so now we've successfully answered the whole of question G, and the final and easiest question is question H. Okay, so in question H, they say what is the equation of the axis of symmetry of f? And now this is a parabola, and on the parabola your axis of symmetry will always in grade 10 be your y-axis, because that is like the halfway point, that is the mirror, and that y-axis is the line where x is equal to 0, right? They're asking for an equation, so you can't say it's the y-axis. No, it's the line x equal to 0. And that concludes example 38. I hope that this makes sense to you, and you can feel free to pop me a message if you have any questions about this example. Thank you for watching.